So we just started a quick revision of atomic structure chapter by PDF from neapear chemistry book. So we are going to start like we completed these two pages, these 2 to 3 pages. We are going with this page now. So it's like we are discussing isotopes. Before we start, you need to know what is isotopes. So it's like isotopes. Wait. Isotopes is something which have like same or equal atomic number. And atomic number, atomic mass we covered in last video, but they have different atomic mass. That's called isotope. So we are going to start what exactly is written here. So isotope, they are the atoms of the same element. We are different in mass and they are different in mass, number of neutron and proton. The atomic number is equal for all isotopes of an element. Because why this all happened? Because the number defines the elemental type of an atom, and I just told you isotope is simply different in their mass, like not equal, not same, not constant, but different in mass or atomic mass or mass number. That's in isotopes. But the number of proton or the atomic number, that's equal to all isotopes. It's like atomic number should be equal for all. And yes, this is about the isotopes. So the number of neutron which is going to be different between isotopes is the same element as it does for the total number of nucleons. When you see what the nucleon, this means proton plus neutrons. So that's called as mass number or atomic mass. Then this determine the physical properties of an element. Okay, and the number of electron is equal to the number of proton. When you see the number of electron, this would be equal to number of proton in a neutral atom, because in neutral we don't have any charge. So this means number of proton equal to number of electron, and for of net electric charge 0. And this number of electron determines the chemical properties of atom. So it's like this. Oh god, this number you see here, this number of electron determine the chemical properties of the atom, right? I don't know what's happening here. Okay. Then the number of electrons equal to number of proton, or as I just told you. Okay. Then, for example, if we take example of carbon, which is the best example I believe, because in carbon you will see that its atomic mass is 12, sometime 13, sometime 14, because carbon has three isotopes of the same element, carbon. Because with mass number sometimes it's called 12, 13, 14 respectively. So it's like that. And the number of atomic number of carbon is 6, which is like neutral. Like everywhere wherever you will use number of carbon, that would be 6. Atomic number is same, which is 6, which is neutral for all carbon. But and even 6 electron also considered, 6 proton plus 6 electron. But neutron number in the isotopes of carbon are changed. So they change because carbon sometimes taken as carbon 12, 13 and 14, but mostly it's like 12, because 12 is abundant, 6 plus 6, because other we also find like that. So most abundant would be carbon 12. But the neutron number in these isotopes are of carbon are written. So if we see how is that, so carbon 12, you will see that 12 is its atomic mass and 6 is number. So 12 minus 6, this means here atomic mass is 6. When about talking about carbon 13, 13 minus 6 is equal to 7. Carbon 14, 14 minus 6 is equal to 8. Okay, so describe the number and relative energies. S, P, D orbital for the principal quantum number. 1, 2 and 3 are also the 4s and 4p orbitals. Number of subshell is equal to given principal quantum number and their relative energies. As is like we have number of shells. This all describe the number of shells. 4s SPD, we have shells is like 1 electron, 2 electron, 3. In that we have 4 main types. First is S, second is P, third is D, fourth is F. And we also write like SPDF, KL, MN. So it's like this is K, this is L, this is M, this is N. Okay, So yes, they are saying that they have the difference is like from highest, it's like S, which would be the near to the neutral nucleus, then P, then D, then F, and we have principal quantum numbers, which is N1. So for number of subshells it's 1, relative energies of subshell is S, and number of orbital would be 1 orbital. Then when we talk about 2, this mean subshell become SP. So it's like first is S, and then second you can also write like S is first, second you can write SP, third you can write SPD, fourth you can write SPDF. I'm also writing S here for the first. So it's like you can see here number of shells would be S, SP, SPD, FPDF. Number of, because it's increasing 1 2 3 4, so it would be S less than P, S less than P, then less than D, S less than P, less than D, less than F. So then they tells about the orbitals. It's like one orbital here, you can see one orbital first. Here you will see 4, like 1 KLSP. This means here the orbital will become 4, here 9, here 16, because the number increase. And here we have point to ponder. This means the main point which you need to remember, or it's like you can do it, the volume of space in which there is 95% change of finding electron is called. So it would be del. So here is the electron orbital. This means for when we need to find radius, it's like 95% chance of finding electron would be electron orbitals. So yes, this is all for today. The shapes, SPD, orbitals we discuss in upcoming video. Till that, thank you for watching. Bye bye.